I've got an equation for a quadric surface up here, and in a moment we'll see how we can recognize that this is an equation for a quadric surface. I've also got some directions on the board, and we're going to use these directions for the rest of the videos for this section, and you can expect to see similar directions on exams or quizzes when I'm testing you on this material. Now, because they take up a lot of space on the board, I'm going to eventually erase them, so I want to just talk through them right now. I'm asking you to do two things. First of all, I'm asking you to draw the trace, or the cross-sectional curve, in each of the planes parallel to the coordinate planes containing the center of the surface. Okay, so that's going to be 3 planes. If the center of my surface was 2, 0, 0, I'd be concerned about the planes x equals 2, y equals 0, and z equals 0. Now, z equals 0, that's just the xy plane. That is a coordinate plane, and it contains the center of the object. Same thing with y equals 0, that is the xz plane, and that would contain the center of the object because the y value of the center is 0. But I wouldn't be looking in the yz plane, which has as its equation x equals 0. I'd look in the parallel plane x equals 2. Okay, because that's the plane that would be parallel to the xz plane, but that would pass through the center of the object. So I'm always going to start with the planes parallel to the coordinate planes that go through the center of the object. Now, often, because I'm sort of trying to focus on what's new here, and that's just the whole idea of a quadric surface, some of the examples I'm going to choose are going to be nice ones where they're centered at the origin. That's going to mean that the planes that pass through the center will be the coordinate planes. But I want to emphasize that what's important is that we're parallel to the coordinate planes and go through the center. We're always going to start with those planes. But if you keep reading, then I say, or, if necessary, appropriate parallel planes. There will be some times when the plane through the center of the object doesn't really give us enough useful information for graphing that surface, and then we'll move to parallel planes. And as we work through the examples, we'll make note of when it does in fact become necessary to move to a parallel plane rather than the one through the center. Okay, and then the second part is just to sketch the surface in R3. Now, for all of these examples, I'm going to ask you to do both things, to draw all 3 traces and then to sketch the surface in R3. It's possible that at some point in the future, I will just ask you to sketch a surface in R3. If I do that, you can sort of choose. You might choose to draw these traces as a helper to help you sketch your surface in R3. You might be confident enough that you know how to sketch the surface without doing those traces that you can jump right to that result. Just be aware, this can be a way, even if I don't specify that you need to do it, this could be a way to earn some partial credit if you're feeling a little bit sketchy about your sketch. Ha ha ha. Okay, so if I look at this equation here, this one is going to have as its center the origin. Now I can see that because I can see I'm not adding or subtracting any numbers to the x's, the y's, or the z's before I'm squaring them. Now sometimes you might see something like an x squared plus a 4x over 4, something like that. Having some x's in addition to the x squared would also tell me that the center is not at the origin. In that case, what I'd have to do is complete the square in order to rewrite that as x plus or minus a number squared. So that's an algebra skill, completing the square, that we'll need in some examples. But if I'm not adding or subtracting anything to x, y, or z, and I don't have any just x's, just y's, or just z's, it's going to be centered at the origin. And I can recognize that this is a quadric surface because that means I'm concerned with the 3 coordinate planes. The xy plane has as its equation z equals 0. Well, if I plug in z equals 0, that's the curve I'm going to get, and I can recognize that that's an equation for an ellipse. similarly, the xz plane would have as its equation y equals 0. If I plug in 0 for y, that kills off the middle term, and that's an equation for an ellipse. X equals 0 would be the equation for the yz plane, which does pass through the center here. If I plug in 0 for x, that's an equation for an ellipse. Okay. So, let's take a look at our traces. Let's just start in the xy plane. So if I'm in the xy plane, that equation, as we said, is z equals 0. So my equation becomes x squared over 4 plus y squared over 9 is equal to 1. That just kills off that z term. So we're centered at the origin in the xy plane. Notice that 4 is 2 squared, that 9 is 3 squared. So I'm coming 2 away from the center in the x direction, 3 away from the center in the y direction. And so we've got a lovely ellipse like so, that's a little bit taller than it is wide. Okay, let me clear some space here. I'm going to just recopy this equation up here, x squared over 4 plus y squared over 9 plus z squared over 16 equals 1. Okay, so now let's take a look in the yz plane. Well, that has as its equation x equals 0. So that's going to kill off that first term. So my equation is just y squared over 9 plus z squared over 16 equals 1. That 9 is 3 squared. That 16 is 4 squared. This is centered at the origin in the yz plane. Remember, z is going to be my vertical axis. So in the y direction, I'm going to come 3 away from the center. In the z direction, I'll come 4 away from the center. And then I can connect the dots. So we get an ellipse that, again, is a little bit taller than it is wide. All right, so let's see, what's left here is the xz plane. If I look in the xz plane, that has its equation y equals 0. So my equation would be x squared over 4 plus z squared over 16 equals 1. Again, centered at the origin, my 4 is still 2 squared, my 16 is still 4 squared. So in the x direction, I'm going to come 2 away from the center. In the z direction, I'm going to come 4 away from the center. Excellent. So I get this ellipse in the xz plane. Okay, so now I'm ready to try to sketch this in 3 space. Now, when you're drawing your 2-dimensional traces, I expect those to be drawn to scale. So I was drawing tick marks. I was trying to be fairly accurate. When you're drawing your shape in 3 space, I'm going to be a little bit less picky about the scale. I want to just try to sketch this. And I find it's often helpful, at least if it's centered at the origin, to wait to draw in the axes. That somehow the axes just get in my way when I'm trying to draw the shape. Now, if I have something that's centered at a point other than the origin, I usually do like to draw in the axes. But my preference, if it's centered at the origin, is to draw in the axes at the end. And that's something that you can sort of play around with. That's just a strategy that I have found helpful. Okay, but I don't find it helpful if we're centered somewhere other than the origin. And we will do some examples, at least one example, where the center is someplace else. Okay. So I need to basically draw this in 3 space, and I'm going to accomplish that by drawing these 3 cross-sectional curves. A strategy that I would encourage you to employ if you're ultimately going to draw your axes like so that the y and the z-axis actually are perpendicular, then the YZ plane is the one that isn't skewed. So, unless you have a good reason for doing otherwise, and in this case, all of the cross sections are ellipses, so I could start with any one. Unless I have a good reason for starting elsewhere, I'm going to start in the YZ plane. So, I'm going to just draw that, knowing that that one doesn't get distorted at all. So, I'm going to draw an ellipse that's a little bit taller than it is wide. I wasn't concerned about tick marks and measuring things exactly, but I am going to respect the fact that it's taller than it is wide. Now, I need to draw in the traces in the other planes. Now, I might want to remember that in the XY plane, XY plane, I've erased that one, but it was taller than it was wide, meaning that the Y direction was greater than the X direction. I can see that just from the fact that the number under the Y's is bigger than the number under the X's. Now what that means, now the Y direction is left and right, so this is going to be wider left and right than it is going to be coming forward and back. So I'm going to just try to draw in that cross section. So an ellipse here that's a little bit wider than it is coming forward and back. And then I can draw in the curve in the XZ plane. Notice the front section I'm drawing solid and the back section I'm drawing as a dotted line. You'll also notice that I made the front section a little to the left because coming forward we're going to represent as coming left and down. Okay. So there we've got that. Now I'm going to go ahead and draw in my axes. Okay. So there we've got our quadric surface, and this one, if all of the traces that we get are ellipses, it's called an ellipsoid. That would be the name of this particular quadric surface.